welcome to DEITV. This is your host, Salomon Alcocer Guajardo. Today's episode we will cover the different types of diversity indices. This will be consistent with episode 1, 2, and 3. And again, the reason for reviewing the Simpson index or indices is because the Hurlbert index is based on the Simpson index. So we'll review the Hurlbert indices after reviewing the Simpson index. Consistent with the previous episodes, I'll apply the Hurlbert index or indices to ethnic data, gender data, and also to revenue data. I'll discuss additional resources, and then finally I'll briefly discuss episode 5. As mentioned in the previous episodes, there are probability-based indices and logarithm-based indices. The probability-based indices include the Hurlbert index, which will be discussed in this episode, the Kovtsev indices, the McIntosh index, which was presented in episode 3, the Simpson index, which was presented in episode 1, the Smith and Wilson indices, which were presented in episode 2, and the Wilcox index, which will be reviewed in the following episode. The logarithm-based indices include the HEAP or HYPE index, the Hill index, the Hurlbert logarithmic index, which will be discussed, the Shannon index, which is the basis for the HEAP, Hill, Hurlbert, Sheldon, and Smith and Wilson indices. After discussing the Shannon index, I'll discuss the Sheldon index in a future episode, and then the Smith and Wilson logarithm-based index, which was again covered in episode 2. As stated in the beginning of the episode, I'm going to review the Simpson indices very quickly. In episode 1, the Bias-Simpson diversity index was presented and discussed. Recall that there is a Simpson concentration or similarity index. That index is constructed or composed of the sum of the frequencies squared divided by the total number of individuals in an organization squared. So that is the sum of small n squared divided by big N squared. That is the concentration index. When you subtract that from 1, that gives you the diversity index. Another way of writing the formula is the sum of the percentages of each of all the individuals in each category. So that's p squared. Again, that's also the Simpson concentration index or similarity index. So you subtract that from 1, that gives you the diversity index. That can also be written very simply as 1 minus the Simpson concentration or similarity index. As discussed in episode 1, there's also an unbiased Simpson diversity index, which is more complex. In order to obtain the unbiased Simpson diversity index, first we obtain the unbiased Simpson concentration or similarity index, and that's going to be the frequency or the number of individuals in each category times the number of the individuals in each category minus 1. We're going to sum that up, so that's going to be the sum of small n times small n minus 1. You can divide that by the total number of individuals times total number of individuals minus 1. And that's represented by a capital N times capital N minus 1. Again, that's the Simpson unbiased concentration or similarity index. When you subtract that from 1, that gives you the Simpson unbiased diversity score. Another way of writing that is 1 minus the unbiased Simpson concentration or similarity index. Recall that there is a biased Simpson standardized or evenness score. That is obtained by dividing the Simpson diversity score by the Simpson maximum score. And recall that the maximum score is based on the number of groups or categories minus 1 divided by the number of groups. So that's represented as k minus 1 divided by k. When the maximum value for a sample or a population or an organization is divided into the Simpson diversity score, that gives you the evenness or standardized score. And recall that that is interpreted as the percentage of diversity that is obtained given the maximum score. So it's the probability It is the total percentage of the maximum score that is obtained. In addition to calculating a biased Simpson evenness or standardized score, there's also the unbiased Simpson standardized or evenness score. That is obtained by dividing the unbiased Simpson diversity score by the maximum score. And that's, as the formula indicates on this slide, that's going to be 1 minus the sum of the frequencies times the frequencies minus 1 divided by the total number of individuals, capital N, times the total number of individuals in the organization minus 1. So that's going to be capital N times capital N minus 1. You divide that by the maximum score, which is represented as the number of groups minus 1 divided by the number of groups, or K minus 1 over K. Again, that gives us the unbiased Simpson evenness or standardized score. In episode 1, again, we discussed the Simpson biased and unbiased scores. So in the far right, there is or the far left, depending on how you're viewing this, you have the biased and unbiased Simpson scores. So you have the Simpson concentration score on the top, which is 0.611. Again, you subtract that from 1, that gives you the diversity score of 0.359. And then when you divide the 0.359 by the maximum score, that gives you a Simpson biased standardized score of 4.87. The unbiased Simpson concentration score is 0.607. When you subtract that from 1, that gives you 0.393. When you divide the 393 by the maximum score, that gives you a standardized unbiased score of 492.492. Then we discussed the Smith and Wilson probability and logarithm based indices. Again, that's based on the Simpson index. So in the middle of the slide, you see the probability based and logarithm based Smith and Wilson indices. Again, because the Smith and Wilson indices are based on the Simpson index, you have the same Simpson concentration score of 0.611. Then you have in the middle column there, in the middle, you have the Smith and Wilson diversity score of 1.638, and that is based on the inverse of the standardized score. And then you divide that by, again, the maximum score. In this case, it's going to be the number of groups. That gives you a Smith and Wilson probability based score of 0.328. Then you have underneath that, you have a logarithm based Smith and Wilson index. Again, that's going to be the concentration score of 6.11. You take the logarithm of that number, that's going to be 0.493. You subtract that by the logarithm of the number of groups or categories. That gives you a logarithm based evenness or standardized score of 0.307. On the last column, we discussed the McIntosh indices in episode 30. So you have the McIntosh evenness score, McIntosh diversity score of 0.219. That's if you're using frequencies. When you divide that by the maximum possible McIntosh index score, that gives you a standardized or evenness score of 0.395. So that's how those indices that we discussed in episode 1, 2, and 3 respectively compare to each other. And again, in this episode, we're going to apply the Hurlbert index to the same data that was used in the previous episodes, and then we'll compare the Hurlbert index scores to the Simpson, Smith and Wilson, and McIntosh index scores. As I stated earlier, the Hurlbert indices are based on the Simpson index. So the Hurlbert indices were created by Stuart H. Hurlbert in 1971. Again, they are based on the Simpson index. They have an empirical range ranging from 0 to 1 is applied to qualitative-based data reported as frequencies or as percentages. Again, it is probability-based, and it produces standardized or evenness scores. The first Hurlbert index is represented as the total number of individuals in an organization divided by the total number of individuals in the organization minus 1. In other words, it's going to be capital N divided by capital N minus 1. As I stated, the Hurlbert index is based on the Simpson index. So you take the product of N divided by capital N minus 1 times the Simpson diversity index. And recall, one way to represent the Simpson diversity index is 1 minus the sum of the percentages of each group squared. Symbolically, that's represented as 1 minus the sum of p squared. Hurlbert states that this index is the probability of two individuals of different groups interacting with each other. Again, the data is applied to the same ethnic data that was applied, or that was used in episode 1, 2, and 3. So here, for example, for the Asian work group, you have two individuals. Divide 2 by the total, which is 100. That gives you a 0.02. When you square that, it's 0.004. And you do that for the black work group, the Hispanic work group, the white work group, and some other race or ethnic group. You get those percentages times themselves, or you square them. So that's going to give you the sum of p squared. Again, that's the concentration, the Simpson concentration score. When you divide that from 1, that gives you the Simpson diversity score, which is 0.393. When you multiply the Simpson diversity score by 100 divided by 99, that gives you the Hurlbert score of 0.393, and that's significantly lower than the Simpson standardized score, which is at the last column, of 0.487. So that is the Hurlbert index of diversity, or Hurlbert index of probability of interaction amongst ethnic groups. Now, unlike the Simpson method or formula for obtaining the maximum score, recall that the Simpson maximum score is obtained by the number of groups minus 1 divided by the number of groups. So that is represented as k minus 1 divided by k. For the Hurlbert index, Hurlbert calculated the maximum value of the index as the total number of individuals in the group or an organization divided by the total number of individuals in the organization minus 1. So it's going to be capital N divided by capital N minus 1 times the maximum Simpson score. And again, that's going to be k minus 1 over k. So in this example, if you look at the bottom portion of the slide, the Hurlbert maximum score is going to be 100 divided by 100 minus 1 times 5 minus 1 divided by 5. So that is going to be 1.01 times 0.80. So when you multiply those products together, that gives you a maximum score of 0.808. And recall that the maximum score for ethnic group for the Simpson score is 0.80. And again, that's going to be 5 minus 1 divided by 5. That gives you 0.80. So the maximum score that is obtained for the Hurlbert index is slightly larger than the maximum score obtained for the Simpson score. Hurlbert also calculated a minimum score, and the minimum score is calculated by multiplying two terms. The first term is the total number of individuals in an organization, capital N, divided by the total number of individuals in an organization, minus 1. So that's N, capital N minus 1. So for the first portion of the formula, it's going to be N divided by N minus 1. The second portion of the formula has a numerator and a denominator. The numerator is composed of two terms. The first term is 2 times the total number of individuals, capital N, minus the number of categories in the organization, or the categories that are used to classify individuals. So the first term of the numerator is 2 times capital N minus K. The second term of the numerator is the number of categories minus 1, so that's K minus 1. So the numerator is again composed of two terms, 2 times capital N minus K times K minus 1. The denominator is the total number of individuals squared, so that's capital N squared. So when you apply that to the data, remember there's 100 individuals in this sample. The number of ethnic groups is 5. So the first portion of the formula requires that it be the total number of individuals divided by the total number of individuals minus 1, so that's 100 divided by 100 minus 1. You're going to multiply that to 2 times 100 minus 5 times 5 minus 1, divide that by 100 squared. So when you apply the formula to the data, you get a minimum score of 0.078. So that's a little larger than the minimum empirical value of 0. So in general, the minimum score that I was obtained for the Hurlbert index is going to reach close to 0, but not quite, based on the total number of individuals and the number of categories that are in the sample or in the organization or in the data that's being used. So again, in comparison to the Simpson index, it just calculates a maximum score. Hurlbert's index has a maximum score and a minimum score that is based on the number of individuals in an organization and the number of categories number of categories that are used to classify individuals based on some demographic characteristic. Now, Hurlbert also developed the relative index of diversity, and that is based on the Hurlbert index of diversity. And recall that the Hurlbert index of diversity is calculated by multiplying capital N minus capital N minus 1 times the Simpson index, which is 1 minus the sum of p squared. So again, that's the Hurlbert index. So to calculate the relative index of diversity, you subtract the minimum score from the Hurlbert index, divide that by the maximum score minus the minimum score. So when you apply that to the data that was used in the previous slides and in the previous episodes, when you apply the data to the formula to the data, you get a Hurlbert index, the diversity index of 0.393. Recall that the minimum score is 0.078. So 0.393 minus 0.078 gives you 0.315. For the denominator, it's going to be the maximum score, and for the Hurlbert index, that's going to be 0.808. You're going to subtract the minimum score from the 0.808. That's going to give you a product of 0.730. So when you divide the 315 by the 730, that gives you a relative index score of 0.431. So that gives you the relative probability that two individuals of different ethnic groups are going to interact with each other or come in contact with each other. So that's how you interpret this index. Again, you have a 33% chance that two individuals are going to come in contact with each other. Again, that's the relative probability or the relative index of diversity. As I mentioned earlier, I was going to compare the Hurlbert indices to the Simpson, Smith & Wilson, and McIntosh indices. Recall that the Bias-Simpson standardized score is 0.487. The unbiased Simpson standardized score is 0.492. When we look at the Smith and Wilson probability-based standardized score, that's 0.328. The logarithm-based Smith and Wilson standardized score is 0.307. In episode 3, the standardized evenness score, standardized or evenness score for the Macintosh index was 0.395. When I applied the first Hurlbert index to the ethnic data, that gave me a diversity score of 0.383, which is more consistent with the Macintosh evenness score, standardized score, and more in line with the probability-based Smith and Wilson index score. The relative probability-based Hurlbert score is 0.431, and so the relative diversity score generated by the Hurlbert index is more in line with the unbiased Simpson diversity score of 0.492. And recall that the Hurlbert relative diversity index score is obtained by subtracting the minimum score from the diversity score divided by the minimum score subtracted from the maximum score. That gives us a relative probability. So in the case of the Bias-Simpson score, the standardized score of 0.487 indicates that the organization obtained roughly 49% of the maximum value of diversity possible. When the unbiased Simpson diversity score or standardized score is used, again that indicates that 49% of the maximum value of diversity was obtained. When we look in the middle column at the probability-based Smith and Wilson index, that indicates that roughly 33% of the maximum value of diversity was obtained. When we look at the Smith and Wilson logarithm-based index, that indicates that approximately 31% of the maximum value of diversity was obtained. For the Macintosh index, that's roughly 39% of the maximum value of diversity was obtained. When you look at the Hurlbert index of diversity of 0.393, there's two interpretations for that. That is, the first is there's a 39% chance that two individuals of different groups, ethnic groups, are going to come in contact with each other. Or you can also interpret that as there's a 39% chance that two individuals selected at random will be of a different ethnic group. When you look at the relative probability of interaction, or the relative index score of 0.43, that's 43%. Again, if you look at it, a probability of interaction, that's there's a 43% chance that two individuals from two different ethnic groups will come in contact with each other. Or it's 43% of the relative probability score was obtained. So that's how you interpret the Simpson against Smith and Wilson, Macintosh, and the Hurlbert indices. Now that I discussed the Hurlbert index of diversity and the Hurlbert relative index of diversity, I'm going to apply those formulas to the gender data, ethnic data, and gender by ethnicity data that were presented in the previous episodes 1 to 3. Again, I'm going to obtain the Hurlbert evenness score or standardized score, and also the relative diversity score. I'm also going to, consistent with episodes 1 through 3, I'm also going to apply the index with the indices to the revenue data that was presented in the previous episodes. As I mentioned a few seconds ago, I'm going to apply the Hurlbert indices to the same gender, ethnicity, and revenue data that was presented in episodes 1 through 3. So let me go to Share. So here I'm going to apply again the Hurlbert Index of Diversity and also the Hurlbert Relative Index of Diversity to the gender data that was presented again in episode 1 through 3. Recall that the Hurlbert indices are based on the Simpson index. So again, just to repeat from the previous episodes, have an organization here that's composed of 100 individuals. 65 are males, 25 are female, 5 of some other gender group, and 5 that are unclassified. So the percentage for the male group is 65%, 25% of the organization are female or women, 0.05%, or excuse me, 5% are of some other gender, and 5% are unclassified. Again, that gives me a total percentage of 100. There are 4 gender categories, so K is 4. Recall that I can calculate the Simpson concentration or similarity score using the frequencies or using the percentages. And again, to calculate using the percentages, I'm going to square each percentage. And here, as you see in the formula, consistent with the previous episodes, I use the power function. You can also just square the numbers by very quickly. Let me just put equals. So an I6, in order to square a number, is going to be equals parentheses 0.65. This is B5 times B5. That's 0.4. That's 0.4225. I can just drag it across the rows, and again, that's going to equal 100. So I times it by itself. Excuse me. Let me correct that formula and go to the sum. So the sum of the probability, excuse me, the sum of the percentages squared is 0.490. Again, that matches with the 0.490 for the concentration score. So I can again do it 2 ways. I can use the power function. And again, in Excel, that's going to equal parentheses, parentheses, power, parentheses, B5, comma 2, parentheses, and parentheses. And again, that's for the 65. I replicate that power formula for the number of women. So it's going to be C5. So it's power, parentheses, C5, comma 2, and parentheses. And I do that for each subsequent group. Again, that's going to be 0.490. Recall that the Simpson diversity score is basically 1 minus the concentration score. So 1 minus 0.490 gives me the 0.51. So with that data, I can calculate, let me go to M5. I can calculate the Hurlbert Index of Diversity. And recall that it's going to be the total number of individuals in an organization minus the total number of individuals in an organization minus 1. In this case, when I use percentages, it's going to be 100 divided by 100 minus 0.01. And then I times that by the Simpson index, 0.510. In this case, is going to be J5. So that gives me a Hurlbert index score of 0.51 or 0.52. This score of 0.515 or 0.52 indicates that there is a 52% chance or probability that two individuals of different gender groups are going to come in contact with each other. Now, in order to calculate the relative diversity score, I have to calculate the minimum score and the maximum score. So let me go to the maximum score. Again, I'm using the percentages. So if I'm using percentages, it's going to be 100 divided by 100 minus 0.01 times k minus 1 divided by k. So in this case, it's going to be 4 minus 4 divided by 4. And the formula here is going to be h5 minus 1 divided by h5. That gives me the maximum score of 0.758. The maximum score for the Simpson index is 4 minus 1 divided by 4, so it's 3 divided by 4, which is 75. So again, the Hurlbert index gives me a slightly larger maximum score. To calculate the minimum score, remember the formula is going to be the total number of individuals in the group and organization divided by the total number of individuals in the organization minus 1. I'm going to multiply that by the total number of individuals in an organization times 2 minus the number of groups. In this case, it's going to be 4. Then I'm going to times that by the number of the number of categories minus 1, divide that by total number of individuals squared. So that long formula gives me the minimum value. In this case, the formula reads as parentheses F4 divided by parentheses F4 minus 1 and parentheses times parentheses 2 times F4 parentheses minus H4 and parentheses times parentheses H4 minus 1 and parentheses divided by parentheses F4 times F4 and parentheses. So the minimum score is 0.059. So when I use those minimum and maximum scores to calculate the relative diversity score using the Hurlbert index for gender, the call is going to be the Hurlbert index minus the minimum divided by the maximum minus the minimum. So in this case, it's going to be 515 minus 0.059 divided by 0.758 minus 0.059. That gives me a diversity score of 0.653. So that is the relative probability that individuals of different ethnic groups will come in contact with each other. So that's how you apply the Hurlbert diversity index and the Hurlbert relative diversity index to gender data. And again, this gender data is the same that was used in episode 1, 2, and 3. So now let me move on to how to apply the data, how to apply the formulas to ethnic data. So let me stop sharing. And now let me move on to the application of the formulas to the ethnic data. And here's the same ethnicity data that has been presented in the previous episodes. So I have the ethnic data, and for each ethnic group, I have the number of Asians in the workforce. I have the number of Black employees. I have the total number of the Hispanic workforce, white workforce, some of the race. Again, I have 100 individuals. As I mentioned in episode 1, this is a quick review of the Simpson indices. Again, the Hurlbert indices are based on the Simpson index. So here we have 5 categories, so a K of 5. I calculated the Simpson concentration or similarity index. Again, in this case, I used the frequencies and I used the power function in Excel. So there's the formula. Again, each frequency is squared. So when you square an individual, you times it by itself. So when I use the formula, it's going to be 5 times 5 for the Asian group. It's going to be 20 times 20 for the Black workforce, 15 times 15 for the Hispanic workforce, and so forth. Now, when you use frequencies, you have to square each frequency for each category, and then you have to divide the total number of the total product of the frequency squared. You have to divide that by the total number of individuals in the organization. So this is going to be 100 times 100. When you use the power function, it's going to be G4, 2. So it's going to be, in Excel, it's going to be power, parentheses, G4, 2. And then there's 3 in parentheses to encompass the whole formula. So that gives me a concentration score of 0.325. Recall that the Simpson index is going to be 1 minus the similarity score, so it's going to be 1 minus 0.325. That's going to give me a 0.675 diversity score. In order to get the Simpson evenness score, that's going to be, just let me do that very quickly. So to get the maximum score, it's going to be 5 minus 1, k minus 1, divided by 5k, and put equal. So the maximum score is 0.80. So if I want the Simpson evenness or standardized score, is going to be 0.675. I'm going to divide that by the 0.80. So that gives me a 0.844. So that means for this organization, I obtained 84% of the maximum value of 0.80. Now, DH1 is the Hurlbert Diversity Index. Remember, that's going to be the total number of individuals divided by the total number of individuals minus 1 times the Simpson index. So in this case, it will be 100 times 99 times Simpson index of 0.675. That gives me a value of 0.682, indicating that there's a 68% chance that 2 members of different ethnic groups will come in contact with each other. Now, the relative Hurlbert index for ethnic group, recall that it's going to be the diversity, this is going to be the Hurlbert index minus the minimum score divided by the maximum score minus the minimum score. Again, like I did in the previous segment, the maximum score is going to be the total number of individuals times the total number of individuals minus 1 times the number of groups minus 1 divided by the number of groups. So in this case, it's going to be k equals 5. So it's going to be 4 divided by 5. When I apply that formula to the data, that gives me a maximum score of 0.808. Now, to obtain the minimum score, it's a little bit more complex. Again, it's going to be the total number of individuals divided by the total number of individuals minus 1, times that by 2 times the total number of individuals minus the number of groups, which is 5, times the number of individuals minus 1, in parentheses, divided by total number of individuals squared. So when again, there's the formula. So it's going to be 100 minus 100 minus 1 times, parentheses, 2 times 100 minus 5 times 5 minus 1, in parentheses, divided by 100 times 100. That gives me a minimum value of 0.079. So to calculate the relative diversity score, again, it's going to be the Hurlbert score of 0.682 minus 0.79 divided by the maximum score of 0.808 minus the minimum score of 0.079. So that gives me a relative diversity score of 0.827. Again, there's a relative probability that two individuals of different ethnic groups will come in contact with each other. It also means that the organization obtained 83% of the relative maximum score. Again, that's applying it to the ethnic data. Consistent with episodes 1 through 3, I have the ethnic groups and the gender composition for each ethnic group. Now the formulas become more complex with more individuals or more categories. Again, I still have 100 individuals. K in this instance increases to 20. Because there are 20 different data points, I have to square each frequency. Again, that becomes more complex as the number of groups increases. I use, again, consistent with the previous episode, in particular episode 1, I used the power function Excel to square each frequency. When I do that, I get a product of 0.168, which is the concentration score. Again, to obtain the diversity score, I subtract the concentration score from 1. That gives me a Simpson diversity score of 0.832. So when I apply the Hurlbert index for the diversity score, it's going to be, again, 100 divided by 100 minus 1 times the Simpson diversity score of 0.832. So when that product is, when the product is obtained, I get a diversity score, a Hurlbert diversity score of 0.840, which is fairly consistent with the Simpson diversity score. However, in order to obtain the Simpson standardized or evenness score, let me calculate the maximum score very quickly. So it's going to be equals parentheses 20 minus 1, in parentheses, divided by 20. Or could I just use the cells? It gives me a value of 0.95. So when I divide the 0.832 by the 0.95, that gives me a Simpson standardized score of 0.87, which indicates that the organization obtained 87% of the maximum value of 0.95. And again, it's pretty consistent with the Hurlbert index. Excuse me. Now, to obtain the relative diversity score, again, I have to calculate the maximum score. Again, that's the same formula applied to the same data. Again, that's going to be 100 divided by 100 minus 1 times the number of categories, which in this case is going to be k minus 1 divided by k. So when I multiply those two products, I get a maximum score of 0.960, again, slightly larger than the maximum score for the Simpson index. The minimum score becomes more complex again because of the formula. So that's going to be, for the first part of the formula, it's going to be, again, total number of individuals divided by total number of individuals minus 1. So in this case, it's going to be 100 divided by 100 minus 1, or AA4 divided by AA4 minus 1. And I'm going to multiply that by the product of the number of individuals in the group times k minus 1. In this case, it will be 2 times 100 minus 20 times 20 minus 1. Then I'm going to divide that by the total number of individuals squared, which is going to be, in this case, 100 times 100, or the cell number is going to be AA4 times AA4. So when I apply the formula to the data, I get a minimum score of 0.345. That's the minimum score possible based on this data. So in order to calculate the relative diversity score for ethnicity and gender, again, that's going to be the Hurlbert diversity score of 0.840 minus 0.345 divided by the maximum score, 0.960, minus the minimum score, 0.345. And that's going to give me a relative diversity score of 0.805 or 0.81. Again, indicating that there's 81% chance that two individuals of a different ethnic and gender group will come in contact with each other. It also indicates that 81% of the maximum relative score was obtained. Now I applied the formulas to the contingency table for ethnicity and gender that was again presented in episodes 1 to 3. Again, there are 65 males in the organization, 25 women, 5 of some other gender, 5 that are unclassified, for a total of 100. Amongst the males, I have 3 Asians, 13 black males, 10 Hispanic males, 34 white males, 5 of some other race. For the women, I have 2 Asian women, 4 black women in the workforce. I have 4 Hispanic women in the workforce, 13 white women in the workforce, 2 of some other race. Again, that's a total of 25. So I can obtain the Hurlbert diversity scores for each ethnic group and gender. So for males, again, there's k equals 5. The Simpson standardized score, the Simpson concentration score, is going to be the frequency for each ethnic group by male. squared. So it's going to be 3 times 3 for the Asians, 13 times 13 for the black men, 10 times 10 for the Hispanic men, 34 times 34 for the white males, and 5 times 5 for some other race. Again, I use the power function in Excel. I'm going to get the product of each frequency squared, and then I'm going to divide that by the total number of individuals squared, so it's going to be 65 times 65. So that gives me a concentration score of 0.345 for males by gender. Again, all I need to do is just copy that formula down the column, and I obtain 0.334 for the number of women by ethnic group. Again, if I want to get the Simpson diversity score, it's going to be 1 minus the concentration score. So for the diversity score for males by ethnic group, it's going to be 1 minus 0.345, and that gives me a diversity score of 0.655. Again, I just copy that down. So then when I multiply 65 minus 1 times the Simpson diversity score of 0.655, I get a Hurlbert score of 0.665. Again, if I want to get the Simpson standardized score, I get 5 minus 1 divided by 5, and I divide that into the Simpson score of 0.655, and that gives me the percentage of the diversity, the percentage of the level of diversity that was obtained given the total possible value of diversity. To obtain the Hurlbert relative diversity score, I have to calculate the maximum score. Again, that's going to be 65 divided by 65 minus 1 times k minus 1 divided by k, or the Simpson maximum score. So for the male group by ethnicity, I get a maximum score of 0.813. The minimum score, if I use the formula, I get a minimum score for the male by ethnic group of 0.120. So to obtain the relative diversity score, I get the 0.665 divided by, subtracted by 0.120, divide that by the maximum score of 0.813 minus the 0.12. So when I do that, I get a relative diversity score of 0.787, indicating that there is a 78% chance that two individuals of two males of different ethnic groups will come in contact with each other. But there's the relative probability. The other interpretation is that 78% of the relative maximum score was obtained. I also want to alert you that the Hurlbert relative diversity score has the potential to generate invalid or undefined scores. That is when the total number of individuals becomes extremely small and the k equals the number of groups, the number of individuals in the organization. So here k is 5 ethnic groups are a total of 5 individuals. So when you apply the formula for the Hurlbert maximum score, that it's going to generate a value of 1. The minimum is going to be the same, 1. So when you subtract the diversity score for some other race, some other gender by race, you get a Hurlbert diversity score of 0.80. So when you subtract the minimum score of 1 from the 0.80, you get negative value. You get a 0 when you subtract the maximum value by the minimum value, so you get an undefined Hurlbert relative score when for some other gender and unclassified. Again, consistent with episodes 1 to 3, I applied the same formula to the same gender data for each ethnic group. So in column B and B14, I have 4 gender categories for the Asian women, the same for the Asians, same for the Black workforce, same for the Hispanic workforce, all the way to some other race. I calculated the Simpson concentration score, again using the power function. I obtained the Simpson diversity score, which is 1 minus the concentration score. So in this example, the concentration score is 0.52. So when I subtract 0.52 from 1, I get 0.48. That's the Simpson diversity score. When I applied the Hurlbert diversity index to the Asian work group of 5, and it's going to be 5 divided by 5 minus 1 times the Simpson score. So in this case, it's going to be 5 divided by 5 minus 1 times 0.480. That gives me a Hurlbert diversity score of 0.60. Again, just to be consistent with the other episodes, if I drag that formula across, then it calculates all the diversity scores for the Black workforce, Hispanic workforce, all the way through the Hispanic workforce, to some other race. It also gives me the level of diversity for gender for the department. I also want to alert you to again, when you apply the relative formula, the formula for the relative diversity score for the Hurlbert index, you get a nonsensical value. In this case, I get a -8 for the relative diversity score for the Asian workforce for gender. And I get valid values for the other ethnic groups and gender. So consistent with the episode 1 through 3, I'm going to apply the Hurlbert indices to the 20 frequencies in the constituent table. So again, I have 20 groups, so K equals 20. Rather than using the power function in Excel, I multiplied each frequency by itself. So for example, for the number of Asian males, it was parentheses, B5 times B5 in parentheses. Then I added that to the squared frequency for the women Asians. So that's going to be B6 times B6. Then I did that for the frequency of Asian women in some other gender group. That's going to be B7 times B7, which is 0 times 0. And I did that for the unclassified Asians. So that's B8 times B8. Then I did the same thing for the Black workforce, for males, females, some other gender, and unclassified. And I repeated that same process all the way to get to the some other race, unclassified, which is F8 times F8. And recall that when you use frequencies, you have to divide that by the total number of individuals in the organization times the total number of individuals in the organization. So in this case, it's G9 times G9. So that's 100 times 100. That gives me the Simpson concentration score of 0.168. Again, if I subtract that from 1, that gives me the Simpson diversity score of 0.832. In order to obtain the Hurlbert index for gender and ethnicity combined, it's going to be the number of individuals in an organization divided by the number of individuals in an organization. Times the Simpson diversity score. So that's going to be G9 divided by G9 minus 1 times 0.832. So that gives me a Hurlbert diversity score of 0.840. Again, to obtain the Hurlbert relative diversity score, first I have to get the maximum value. We call the maximum value is going to be the total number of individuals in an organization divided by the total number of individuals in an organization times K minus 1 divided by K, or the Simpson maximum score. This gives me a value of 0.960. Again, to obtain the minimum score, it's going to be the total number of individuals in an organization divided by the number of individual organization minus 1. I'm going to times that by the product of 2 times the total number of individuals in an organization, which is 100, minus the number of groups, or K. Again, that's going to be, in this case, it's going to be G24 equals 20 times G24 minus 1, which is 20 minus 1. Then I'm going to divide that by the total number of individuals in the organization squared, so that's going to be 100 times 100. That gives me a minimum value of 0.345. And again, in order to obtain the relative diversity score, it's going to be the Hurlbert diversity score of 0.840 minus the minimum value of 0.345. I'm going to divide that by the maximum value minus the minimum value. So that's going to be 960 minus 0.345. That gives me a relative diversity score of 0.805, indicating that there's an 81% chance that individuals of a different ethnic and gender group will come in contact with each other, or that the organization obtained 81% of the relative maximum score of 0.960. So that's how you apply the Hurlbert diversity scores to a contingency table for all the frequencies inside that table. Let me stop sharing. So now what I'm going to do is I'm going to apply the same formulas to the revenue data that was included in the previous episodes. This last segment of the application applies the Hurlbert indices to the revenue data that was presented in previous episodes. So let me go to share. And this is the revenue data that was presented in the previous episodes. I have $80,000 in corporate donations, $150,000 in individual donations, $45,000 in fundraising revenue, $10,000 in investments, $18,000 in grant revenue, for a total of $403,000. If I get the percentage of corporate donations, that's 20% of the total. Individual donations represent 62% of the total. Fundraising 11%, investments 2%, grants 4%. There are 5 revenue sources. Again, I can use the frequencies to calculate the Simpson concentration or similarity score. I can use the percentages. Again, whether I use frequencies or percentages, I gotta square each frequency and percentage. In the case of the frequencies, I got to, again, square each frequency for each revenue category, sum each of those products, and then divide by the total revenue, which is 403,000 times 403,000. For the percentages, all I do is have to square them up and then sum them. So that gives me a concentration score of 0.439. Again, if I subtract the concentration score from 1, that gives me the Simpson diversity score. So when I do that, it's going to be 1 minus the 0.439. It gives me a Simpson diversity score of 0.561. I'm going to show you one of the quirks of the Hurlbert diversity score. If I use frequencies, that's going to be, again, total number of revenue divided by total revenue minus 1. So it's going to be G4 divided by G4 minus 1 times the Simpson diversity score of 0.561. So when I use the frequencies, that gives me a Hurlbert diversity score of 0.561. When I use the percentages, again, that's going to be 1 divided by 1 point, it's going to be 1 divided by 1 minus 0.001 times the diversity score of 0.561. Again, so when I divide 1 by 1 minus 0.01 times 0.561, that gives me a Hurlbert diversity score for revenue of 0.566, which is slightly larger than the Hurlbert diversity score if I use frequencies. Now, when I calculate the maximum score, again, there's a slight difference. If I use frequencies, it's going to be G4 divided by G4 minus 1, which is 403,000, divided by 403,000 minus 1, times K minus 1 divided by K, which is the Simpson maximum value. So when I do that, that gives me a value of 0.8. When I use the frequencies, the percentages, it's going to be 1 divided by 1 minus 0.01 times 5 minus 1 divided by 5. So that gives me a value of 0.808. Again, slightly different when I use percentages and the frequencies. The minimum score is going to be 0. Again, that's going to be the total revenue divided by total revenue minus 1 times 2 times total revenue minus 5 times 5 minus 1 divided by total revenue times total revenue. That gives me a value of 0. And in order just to be consistent, I just copy that value down. So I put equals M4. So to calculate the relative diversity score, again, I got the diversity score minus the minimum score of 0 divided by the maximum score minus the minimum score of 0. When I did that, it gives me a relative revenue diversity score of 0.701. And it's the same for the data using percentages. Again, the 0.701 indicates that the organization obtained 70% of the relative maximum value. And remember, the relative maximum value is the maximum value minus the minimum value. And to be consistent with the previous episodes, I did a what-if scenario. So what if corporate revenue increased from 80,000 to 95,000? I kept individual contributions constant at $250,000. I increased fundraising revenue to $65,000 from $45,000. Investments I increased to $25,000 from $10,000. Grant revenue I increased to $30,000 from $18,000. So I have the percentages. Again, if I use the frequencies, I get the same maximum value, although the maximum revenue increased to $467,000 from $403,000. I get the same 0.808 maximum value if I use the percentages. I also calculated the Simpson concentration score for revenue. In this case, I used the power function. I also used the power function for the percentages. So I get a Simpson concentration similarity score for revenue of 0.355. When I subtract 0.355 from 1, I get a Simpson diversity score of 0.645. Again, to calculate the Hurlbert diversity score, I get the total revenue divided by the total revenue times 0.645. That gives me a value of 0.645. When I apply the same formula to the data obtained by the percentages, I get a slightly larger Hurlbert diversity score of 0.652. Again, the difference is based on whether I use frequencies or if I use percentages. I have the same maximum score, minimum score for the revenue scenario. So when I apply the maximum score, the minimum scores to the diversity score and to the maximum score, I get a Hurlbert relative diversity score of 0.806, indicating that the organization obtained 81% of the relative maximum value. So this briefly is how you apply the Hurlbert indices to the revenue data. And again, this to be consistent with episodes 1, 2, and 3. As I mentioned at the beginning of the episode, there are additional resources that you can use to get a better understanding of the diversity indices. One source is assessing organizational diversity with the HEAP index. That covers the Hurlbert and logarithm index, which will be covered in a future episode, but the methodology that is used for those indices is the same as the presentation that was presented in this episode. A second source that you can use is the assessing the validity of diversity indices. Again, this covers the Simpson index, Smith and Wilson index, the McIntosh index, and also covers the Hurlbert logarithm-based index. The third resource that you can use is assessing organizational diversity with quantile regression. Again, that includes the indices that were discussed in episodes 1, 2, and 3. It also includes the Hurlbert logarithm-based index. Again, the methodology of the formulas that are used to obtain the logarithm-based index, the structure is the same as that is the structure for the probability-based Simpson index. In other words, the logarithm-based index, the Hurlbert developed, also uses the maximum value and the minimum value to obtain a relative diversity score based on the Shannon index. As I explained in this episode, the minimum score, maximum scores are utilized to obtain the relative Hurlbert diversity indices. So the methods are the same. The formulas changed for the probability-based and the logarithm-based Hurlbert index. However, again, the method stays constant. So now that I discussed these sort of additional resources, let me go and talk briefly about episode number 5. Episode 5 will cover the Wilcox index. Like the indices presented in this episode and in episodes 1, 2, and 3, you can use frequencies or you can use percentages. So I'll demonstrate how to apply the Wilcox index to frequencies and also to percentages. And just to review, small n refers to the frequencies, k refers to the number of categories or the number of groups, capital N refers to the total number of persons in the organization. And again, to be consistent with episode 4 and episode 1 through 3, the Wilcox index will be applied to the gender data, the ethnic data, the gender by ethnicity data that was utilized in the previous episodes, as well as the revenue data that was used in the previous episodes. So thank you very much, and I'll see you soon.